Hello, Barshan.
Hello.
Hi. Hello, Morgan. All right. Welcome. Barshan, why don't you give an update to start us off?
Yeah, so I made a PPT telling all the work that I've done till midterm evaluation.
All right.
So I'll just pull that up. So starting with week one and before that, everything. So this is the Napari visualizations which I made for a cell tracking uh, embryo, and so we are also, and this one more that I created during the proposal period, where I am analyzing the Markovian space movement of the cells in the embryo. And this was before the proposal period, and this was consisting, like, it was mostly pulled into the week one as well. And this is week two, where I created a data set, and we have the uh, like I converted the CSV files into the NumPy array so that it can be used better and easily and fetched easily from the and the data can be fetched easily from an embryo. So we have like loaded samples of different embryos, and then we are also seeing the shapes, like how many number of cells are there and how many edges at one timestamp and everything. And then week four consisted of training my model, SGen model, using those CSV NPZ files and some of the train laws and the accuracy we have, where it was around 96% accurate. And so this is what week four consisted of. And then in week five, we have the cell to cell attention weights. Uh, where I extracted the attention and I ran the model through a embryo, and I have extracted the cell to cell attentions and each weight of at each timestamp what we have, and we have this graphs where the cell attention increases at one time stamp for the one of the cells. And after that we have in the week six I created a visualization where we can look through the timestamps of a embryo, and where which cell division is leading the most to the actual cell fate of the embryo. And we can also move through this, and the nuclei and the colors define the different anterior posterior cells, or the different types of cells in an embryo. That's what the color defines. And also the cell size are also included in this, like the size of the actual cell is depicted by the to scale in the UI. And so since I'm already ahead of like for 2 weeks, uh, so next the tool building and visualization, I have to work more on those and create a pipeline, and of course take a buffer of a few days which I'll need, because I need to make sure that the attentions are getting fetched properly. And for the week 10 and 11, I'll integrate this module into the DevoGraph pipeline and try to check out the other previous years uh, projects and see if I can include anything in those. And I also create an interactive function which allows to trace the decision paths, which is like they are using Napari. Like I can trace the path uh, or, or of a single cell which leads to a cell fate. And on the final week, I'll open up a documentation and prepare a report for the final evaluation. Also write a blog, and I'll push in the final changes. That's what you have in the final steps.
Okay, that looks pretty good. Yeah, I see that you're ahead of schedule. So, are there other things like when you proposed your project? Did you propose any stretch goals or other things that you might get to that are maybe were lower priority at the time?
Um, Not really. I think I wrote everything in my proposal right here. But
Okay.
of course, I'm exploring other stuff as well.
Okay. So, what do you think is the most promising of all this? I mean, what do you think is like the best work, and what do you think is the maybe the thing that needs more work on it if you had infinite time?
Maybe actually, I would like to work on collecting data more, since I think the basic foundation of a model will be the data set, and maybe a proper data set if available. I would like to trim it down more to our use cases. Maybe it's available somewhere like a huge data set, but it's not specifically made for using for models like this. It's just there for biological information and not to be integrated into a artificial intelligence model yet. Maybe those
So
kind
what
of
would you
data.
need? What would you need to
So
collect for that?
like as I made a NumPy array using the CSV file, so maybe a proper, maybe a better data set uh, rather than the just the Epic. I mean, you mentioned a few years back you gave a collection of data sets which I have saved, and from that I took the Epic data set itself because it had the most information. But I didn't explore the rest of the data sets, but I did explore it that time. But the Epic dataset had the most number of embryos which are needed to make a model like this.
Yeah, I mean, so yeah, there are other data sets for C. elegans, which have other types of data. So what you have is basically like cell centroid data. You also have some cell membrane data, which it's not the best data set for that, but you can do that, and then
Yeah,
you can
I mean
do
there were
yeah,
yeah there were
and
other
so there are
dataset,
other
but
data sets.
they were about cell tracking, I think. So cell tracking won't be of much use in this one, since we are also taking an account of the cell divisions and everything.
Right, right. But of course, the spatial position is important too, right? Like
Yeah, it
the
is. Yes.
divisions or the lineage tree doesn't give you positions per se. It gives you like an orientation,
Yeah, the
which you could
path of the
use.
cell.
Yeah,
Yes.
but there are other data sets where they have membranes that are stained and marked. So that's something
Hmm.
that can be done because usually what we might do with a centroid data set is infer the membranes from like a Voronoi tessellation or something and find the nearest or the midpoint between two centroids and then use that as a kind of a map for the membranes. But membranes are actually quite complex and they kind of are nonlinear in their shape, and
Yeah.
that's an important thing to characterize. They're also molecular data sets. Now, it's not going to be, well, it would actually be directly tied to the lineage tree, but there's a lot of data that's, like you have gene expression networks, gene regulatory networks that are sort of
Yeah.
indirectly involved in the sort of process of differentiation. So that,
Yeah.
there are all sorts of
So
data. Yeah, go ahead.
well, at first I propose, like, I'll get the cell fate as which part of the cell of the worm it will get, but I can also look into the gene expression and maybe where the in like if gene expression relates to a fate kind of thing, like if gene changes with time or something. I don't have an idea about it, but yes.
Yeah. And then they're, expanding this to other species, other model organisms.
Yes,
So we
of
talk,
course.
C. elegans is like a very unique, or it's a very one mode type of development. There are other types of development. There's, of course, more regulative development. There are embryos that do things like cellularize at certain stages of development. There are other
Hmm.
types of organisms that will undergo metamorphosis, and so things like that are really interesting. But it's the data sets maybe exist, but sometimes they don't exist in a very good way. Like people try to figure out how to measure these things, and so it's not easy to get a data set for those things.
Yeah.
And this is kind of where maybe modeling helps, because if you have some sort of data set for like cell division and characterizing the cell membranes and characterizing developmental time, you could build models of like metamorphosis or other modes of development,
Hmm.
and that would be interesting. Although maybe not as ground truth as we'd like, but it would be an interesting foray.
Yes.
Yeah.
Um,
Okay. So
I mean,
yeah. So
in
that
the field of neuroscience, I think data is a big deal. So if I had infinite time, I would like to polish, a proper data. Like I did polish a data set into that NumPy array, which can be also used for future works. If anyone wants to work in graph neural networks, maybe some other idea or proposal, he can of course use that data set. And it's very helpful in that way. Um, so other than that, if I had infinite time, well, I would like to explore more about some data, if possible. And I mean, this is already my proposal. I'll work on this, of course, but after
yeah. I
this,
know.
if I had
Yeah.
more time, and then I would like to explore more in that sector
All right. Well,
because
I just
data
gave.
seems a lot sparse.
Yeah. So I just gave you a hypothetical. I mean, that wasn't like meant to be like a you need to do this, but yeah, I'm very impressed with what you've been able to do this summer, and you've been working on, a paper already, and of course, to sort of after the summer,
Hmm.
we'd like to be able to write some of this up as well. Maybe
Yeah, of
like an
course.
SGL specific paper. Well, of course, a documentation, but that's just kind of for the user. I mean, maybe like an SGL paper where we come up with some sort of set of tests, or we document
Yeah.
maybe if it's benchmarks or if it's some biological question.
Yep. Sure.
Yeah. So yeah, it's good. You're
I mean,
making good
of
progress.
course, the question can be formulated as does how does each division affect the final uh, fate of the cell, something like that, or does the division really matter? It can be a negation question as well.
Yeah. Yeah. Well, yeah. Like I think I mentioned this that you could, when you in a wild type, which is the sort of the genome that doesn't have any defined mutations in it. You
Mm-hmm.
get cell divisions and they're regular, they're programmed and they're deterministic. Now, sometimes in mutants, you'll have cells that don't divide, or you'll have cells that die, and they
Mm-hmm.
are they serve some purpose in the wild type, but they're just not there in the mutant. And so, people have raised, there are a lot of defined mutants where they're missing certain cells, either in the connectome or in the body, and they have certain behavioral deficits or morphological deficits. And so this is an interesting area because you can model sort of defects, morphological defects, and see what they actually do. And then that we might be able to use that to build like an inverse model of like a gene regulatory network to show kind of what happens if you knock out a certain allele, and it'd be interesting.
Yeah.
We kind of been talking about that for a long time in Devorn, but we didn't have the tools for it. It's kind of a hard thing to get your head around and then to build the tools. But that's something that is always interesting when you're dealing with the whole worm. Is like how can you perturb it to see what that looks like, and then you know what can we match it with in the real world, or can we model some process that generates that, and then there are all sorts of things we can do there. Um,
Yeah.
yeah. All right, that sounds good. Thank you.
All right. Thank you.
So you have a pull request for this week?
I'll put it in next day, tomorrow.
Okay, sounds good.
I put in a request about the UI changes and everything, like you asked. Uh,
Okay,
yeah. I think
did
it
I
was
accept
last
that
week
or
I
not?
put it. I think you did, yes.
Yeah, I think so. But all right, yeah. Thank you.
All right. Yes.
So Morgan, how are you?
Yeah, not bad.
All right.
Uh,
Um, would you like to give an update or?
yeah, it's I mean, mostly. we had a reading group on the Anthropic global workspace. Do we call it a paper? What do we call it? Preprint / press release. um, but I have, I've got I've got a project on my GitHub, Societies of Thought, that is trying to basically, I'm trying to merge, or at least find the overlap in the Blaze Agarasiarchus. Is that his? I think. So he's got this paper from January that is, sorry if this is maybe too cogsci, but there's a repo. And I've tried to, these papers, I think, should be, we should hold them to the same bar as we would hold any computational work, which is that there needs to be code and there needs to be data and there needs to be, something you can run and you can generate the paper's results. And somewhat to Anthropic's credit, they did release something. So they have a I forget what they call it, Jacobian lens or JLens package or project. They don't release Claude. So yeah. So so you still have to do some work to kind of turn it into a reproducible project, or turn it into a reproducible paper. There's some interesting resources that I became aware of because of this paper, Neuronpedia, which is another a website to do kind of mechanistic interpretability modeling. Again, it's like, yeah. Anyway, all of those things are not in the Blaze paper. and so that's kind of what I've been running this particular week. Had a really nice meeting with Arnaud Delorme and I think grad student USC, getting ready for cutting EG. This is international meeting, open source, tools and techniques for EEG, MEG analysis. It's taking place in 10 time zones or something like that. It's going to be pretty awesome. September 21st to 25th or something like that. But it was great. So we'll probably be doing some things with UC San Diego, who are kind of having a local conference. So I was thinking about what are kind of San Francisco things that we could add remotely. I was thinking a bit about prediction in EEG. So open source projects for, there's a company called All Joined, that's one of these MindEye alums. And, maybe we could do a workshop on showing people pictures and predicting those pictures from their EEG activity, and like how you fine tune how you fine tune their model to that particular subject, and then start being able to generate accurate predictions of the pictures that they're looking at. But yeah, that was more on uh, the neuroimaging. Um, and then yeah, it's got some. I can share some great videos on the computational microscopy. There's some really nice tutorials on this that yeah, we could really started talking with some former UCSF people here at the lab about trying to maybe make our own advanced microscope, like a confocal or something um, something that would require some real precision optics, but then still thinking about how to do this kind of computational microscopy. So I've got some videos to share on that, and that I thought they're very good. Think that's it, or I can follow up tomorrow. Um, but I do think these societies of thought is the GitHub repo, and I think like I think got some. It would be nice to come up with not just a this is a criticism of a particular paper, but actually demonstrates robust computational examples of issues with the paper.
That's great, Morgan. Thank you. Yeah, we'll follow up tomorrow probably on some of that. Societies of Thought is. Could you post that repo in the chat? Maybe we'll take a
Yeah,
look at
absolutely.
that. Yeah. So of course there's the Society of Mind from Minsky, right? The famous book. I don't know if it's like
Yeah,
similar name.
it's definitely a nod to that. Yeah. Just the quick story is that he's training. Blaze is trying to show that, like, if he trains a reasoning model to be for its internal dialogue to be more dialogic, that it improves reasoning. And yeah, so interesting that of the benchmark that he uses, he only uses one data set from it. If you look across some others, this pattern does not hold.
Yeah. Yeah, I was digging a little bit into that recently about the reasoning models and how people build them like from scratch. And it's just kind of like a lot of it is like this extra prompting of the model, and you have to kind of figure out the structure. You have to get you have to get the LLM to kind of reconsider its answer or think about it more deeply, but it's very subtle in how you can get it to do that.
Yeah. So it's this is absolutely right. Like the details are important, right? And the Anthropic paper is sort of does a good job of explaining this, but also it's like gosh, I really got to put together. I'm trying to do the Mike X Cullen book on 50 lessons, like what's it called? It's 50. Anyway, the Mike X Cohen is kind of well known in neuroanalysis as a tutor, someone who left academia, and he's got one on trying to understand language models, computationally, and I think it's really important to be able to properly evaluate these papers. and but there is something interesting computationally in the JLens paper. Um, but I think it is really valuable. And the reason I dropped the Emily Bender video in is just that, like, I think I need to watch. I need to listen to her like once a week to reground myself. um, because I love it's just always good, right?
Yeah.
And like her coming at this from a purely linguistics, yes, yes, yeah, um, purely linguistics side, um, where yeah, which is super valuable. And obviously, and she's a computational linguistics person, so it's like she absolutely knows a lot about the kind of mathematical structures that have historically been associated with language, as well as the pragmatics of how we actually go from uh, um, an audio stream to a comprehension, right?
Yeah.
And and some really just valuable parts of that, especially when it's around the like super anthropomorphic terms that uh, maybe weren't solely the responsibility of the authors of that paper and somewhat the marketing department from Anthropic, but are deeply troubling with that particular paper. Anyway, I'll
Yeah.
drop some links. I'll drop some
Yeah.
links. But she's I mean she's just good. She's good.
Yeah.
And again, it's also so important to because it's not that I don't know this, but it's also so important for you to stop once a week and be like, let's just remember the history of intelligence research
Right.
historically as being a deeply, deeply problematic area
Oh
with
yeah.
a bunch of race science behind it,
Mhm.
and that is not good. And it also makes me think about the University College London lecture that they are now required to have because they had to rename so many of the buildings. Uh, uh, they had renamed so many of the buildings that had been named after like awful eugenicists,
Yeah.
and so I forget what the guy's name is. I forget if it's I forget if the series is called Rutherford or if the speaker is Rutherford, but he does
I think
like the dark
Rutherford. Yeah.
history.
Yeah.
It's like the dark history of statistical genetics or something like that.
Hmm.
That is yeah, just really need a reminder on. And so again, it's like if we're going to be yeah, just good to remind ourselves on the history of these particular kind of cognitive science terms,
Yeah.
and how yeah, like how much of a social construct they still really are. Yeah,
Yeah. So you weren't here
yeah.
Wednesday when we talked about so, we were going through the special issue on, from Royal Society A, and we
Okay.
visited the paper by Douglas Hofstadter, which I can't remember the
Uh,
exact title. It was,
okay.
is there an I in AI? I think is the
Yeah,
title.
yeah.
Ah,
Yeah.
okay. Good. Good.
And,
Good. 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 Okay.
he had a couple of choice quotes for different people working in the field. Like, I think he said about like Emily Bender. He said she's part of the Chomskyan mafia or something like that.
Cronies or something like that. Yeah.
Yeah, something like that. So it's not like there's a love lost between different research groups, but I just found it interesting how different people have different kind of takes on that. And but that was a very interesting. Emily
Yeah.
Bender has a lot of interesting takes on like
Yeah.
rooting this in cognitive science, And then that
Yeah.
paper was really interesting because it also rooted it in cognitive science and more appropriately earlier AI research, which a lot of times you don't get with people
Yeah.
doing modern AI research. It's kind of like that just doesn't exist, or we don't need to go
Yeah.
back and cite that. And,
Yeah.
it's like, right.
Yeah. No, for sure, for sure. And I need to get this particular researcher's name, but I'll drop in this review because watching her reminded me of Dare, DAIR,
Right.
and they've got a researcher who kind of certainly seems to be very responsible for their um, blue sky feed or something. um, but a great review on metacognition in LLMs that again, I'll drop links on this, but just making me think of these. And yeah, that sounds like great paper. uh,
So Michael X. Cohen is not the guy from Futurama. He's a different guy, right?
No, yeah, definitely. I mean, he could be that multifaceted. But I believe he's a neuroscientist.
Okay.
Turned independent educator, Udemy, like
Okay.
classes, and writes books on neural data analysis. um, yeah, yeah. But I'll find that book too. I mean, because again, it's just like I want to know where to point people in terms of how to get that kind of. I mean, I'm not saying it should be a neuromatch topic yet, but I would like that kind of um, early, like that kind of rigor.
Undergrad level. Yeah.
Yeah, yeah, approachability, or yeah.
So yeah, I haven't kept up with how Neuromatch is updating their curriculum, but like that might be an interesting thing to, we could do it ourselves, I guess.
Well,
Create a curriculum.
but it's worth it though. I mean, the new, I think they call him a CEO. um but the new CEO is actually an Oxford guy. I mean, American or Canadian, but an Oxford guy. And uh I try not to make that mistake of just assuming a North American accent is an American.
Yeah, well, it's a very different accent. Yeah.
Well, sometimes I've got it wrong before with Canadians, but the uh, he joined a Foresight meeting and was basically saying that, like, they're really interested in kind of more of kind of a formal educational focus, but they honestly just don't. They certainly don't have um, the bandwidth at this time in terms of it's really more about organizing the people, and
Right. Yeah.
and it's cool what they've done in terms of the scholar program, like kind of like giving people opportunities after that, to and making new paths, right? Like that's like super valuable, right? But they were saying all sorts of, he said, when I asked him about it, he said that they even have like video of the pod interactions and things like that. You know, there's material there for some sort of education researcher even.
Oh yeah.
But I would, and did you see that Gunnar Blom, if I'm pronouncing that name right? So the co-director, one of the co-founders of Neuromatch, is starting a new module, which is computational
AICG
behavior.
stuff. Oh yeah. Yeah, that looks really interesting. Also, I kind of came in late. What was the bit about the curriculum development stuff? I just missed part of it.
Well, I was just saying that, like, you know, I was pointing out that Michael X Cohen has a new book on, it's like 50 lessons for, 50 lessons in computational modeling, but of LLMs, like it's both a math book and an LLM understanding book, and um, so I need to do a deep dive on it, or like I need to do it properly, and then hopefully see if what's the best kind of way to support that kind of material in terms of getting students into something that now is like, I mean, again, I don't want to say this is the same as philosophy, but this is like computational cognitive science, right? And um uh in whatever that means, right? Because it's like this is not to say that these are living entities, but again, this is an incredible artifact that generates so much, that is kind of in many ways Turing sufficient. And yeah, just it should be a topic that we can give people a path, right? um and I was just saying, Jesse, that I've got some results that where it's just like I'm combining a paper from Dare, actually, on a particular entropic measure of diversity in language, or like speakers, and then the anthropic paper on global workspace, which uses this Jacobian lens to kind of get at the internals of a model, to approach and extend the Blaise-Agaris Siarchus paper, that's this like reasoning in societies of thought, which I think, yeah. Anyway, and the idea is like I'm still feeling very out of my depth, and so I've actually asked a kind of a machine learning engineer from one of these. I think he's like former Yahoo guy, um, but to kind of review the work, because like maybe I'm missing something in terms of just somebody who really understands the internals of these language models and can tell me, yeah, like what else might there be, something that's confounding your residual stream when you're doing this analysis, for instance. Like, yeah. Anyway,
Yeah.
I'll drop links.
All right. Yeah. Yeah. For Jesse's benefit, we were kind of thinking about like how Neuromatch may have been updating their curriculum. I haven't kept up with it, but it's worth thinking about like what new topics are there that are kind of emerging, because we talk about this all the time in our Saturday meetings. We always come up with new
Yes.
topics that are so. I mean, I don't know, and I said we could make our own, but I don't know who would care.
Well,
But yeah.
I mean, so like I'm asking in part because like I'm looking to point some things that are happening in cognition futures towards some specific outcomes, and I think that might be a nice one that's there. Um, so, but also like we have, the lab has a history of doing this too. So, um, yeah, we can talk about it later. I know I'm
Okay.
kind of coming late here. I'll show you. I don't know what you guys else want to talk about today in terms of the regular meetings, but
Well, I'm gonna do like about a 10-minute thing on a topic that I have, but if you want to do 10 minutes of an update, that's fine.
I will because I
Yeah.
am on location at, of all things, the Isabella Stewart Gardner Museum. So
Okay.
It's like art and things here. I'm in like the public area, so it's not like anything cool.
Is
That
that in
you can
Boston?
see. Yes, it's in Boston.
Okay.
You probably never met Molly, but Molly is someone visiting for the neuroergonomics conference that I spoke about.
Okay.
Um, so I'm kind of snuck off here for to have a bit more a space to talk about. Here's a nice pamphlet to kind of show what it would be. It's more
Okay.
like this, so you can see like yay, nerdy, artsy, cultural stuff, which is definitely what Google Summer is all about. But no, it's been such an interesting time. Um, there's a lot of overlap between some data and direction topics and what we've been talking about here and what we haven't talked about. Um, but I'll just do a brief update of how do I want to say this? Um, Ashley's not here. Was Ashley here earlier? Did she talk about anything? I was going to ask her about some stuff. But,
Yeah, she wasn't here.
She told me that she's sick, so she couldn't attend today.
Okay, because I know I know she sent some updates about her projects, and I haven't been able to look at them. I was actually just traveling. Well, I wasn't here last week because I was traveling. I was traveling in New York, and I, a lot of interesting things happening there, and also happening in terms of like data interaction stuff in general, and Digivest. So I don't know. I don't have anything cool to really drop here other than I'm definitely still thinking about all the papers you've been reading in the special issue of the the philosophical transaction issue because of all the things we talked about here. So I don't know. I was going to say something and now I'm like, I don't have the best way to say it and I can't show some of the stuff, so I'm kind of just backing out. But it's good to be here, and if anybody wants, does anyone present? I guess what else happened earlier today's meeting? I'll go off camera because I'm losing a little bit of bandwidth. But what happened a little bit earlier before I joined?
Just Barshan gave an update on his project, and we kind of came in Morgan's presentation, so he's just giving updates.
Okay.
Oh, good. Barshan got selected for Cloud Open Source Program.
I didn't even know what is that.
So
curious.
basically, they are giving the Claude Max 20x for 5 months or 6 months.
And you apply just because you're working open source stuff, or
Yes. Also, I wanted to
Okay.
work on that. Like, it's very useful. So I thought, why not give a try?
Great. Send me any information about that, and we'll.
They do have a portal. Like, I think Mehul sent it over in the DevWorm. That's where I got it from.
Okay. Because it'll be fun to say, hey, we have someone who got a lot of open source thing too. So that's good. I've been thinking a lot about some of the professional development discussions that we've had. There's some things regarding people here and forming organizations that do research and developing technology in different kind of ways that I can talk more about probably more elsewhere, but lots of good stuff happening. So thanks for sharing. I'll leave it at that, and Bradley can continue with your regular programming. But just wanted to check in.
Okay, yeah, that's great, Jesse. Thank you. Being on location and everything. Let's look at the chat. Yeah, I don't think we got any links here to go over, but
I'm dropping them into the Slack on GSoC,
oh, okay.
or at least my links. Yeah.
Yeah, could you open, or could you share, like, I don't know which ones were most relevant in the chat here?
Sure. Yeah, sorry. I'm on my phone.
Okay,
yeah.
that's fine.
It's getting my Bluetooth to work with my Linux workstation. That's the hard part.
Okay.
Yeah.
Let's see.
But yeah, one sec. All right. I'll
Yeah,
bring them over
Barshan.
from Slack.
Okay. Yeah, Barshan put a link in for Claude. This is the Claude for open source software. So this is kind of their sales pitch for that. The Claude open source program. Yeah, so this is 6 months of Claude Max on us. Who should apply to this program? Maintainers and library authors, core contributors, active contributors, community builders, and critical infrastructure. So this is just, if you're an active contributor and you've authored 100 or more pull requests merged into repos you don't own in the last 12 months, that's pretty active. That's the kind of thing they're looking for. Or if you're a maintainer of a large project, obviously if you're a Google Summer of Code person, because Barshan, definitely this is, I think they're a little ambitious on some of these. But yeah, I mean, that's good. Congratulations, Barshan.
Thank you.
Yeah. Okay, so this was something that I don't know if it was either Jesse or Morgan who dropped it into the Slack, and I picked this up. It was Russ Boldrak, so it must have been Morgan. And this is
Nope, it was me because I
Okay.
found it on where did I see this? He's posting all of these on it's on Substack, which is
it's
quite
a
interesting.
Substack. Yeah, it's his Substack, but yeah, it's basically going to be about from this Better Code, Better Science book, Chapter 3. So it's a kind of a bonus section of that book, Chapter 3, and basically, it's interesting because it's this is a common topic in software engineering, and it's really kind of one of those things where we don't know, we don't have a good answer to this. I mean, the whole enterprise of project management, in a sense, is about managing complexity, and a lot of it has to do with software engineering, because software engineering has been sort of engaged in this for a long time. So I'm interested to see what he has to say about this. He has this open source textbook, Better Code, Better Science. He's releasing sections of it on Substack, but you can get to the book at this link here. And it's released under a Creative Commons license. So, he talks about complexity in software projects. So if you've ever written a large piece of software, you've likely encountered a situation where you start to feel overwhelmed by the complexity of the code. You want to make one simple change, but realize that the apparently simple change has cascading effects that require many different changes across the code base. Or even worse, things unexpectedly start to fail for reasons that you can't understand, and every fix causes a new error. You might even get a headache and decide to go do something more pleasant, like flossing your teeth or doing burpees. I mean, you could do that, but some people like complexity, but I get the sentiment. These are the symptoms of complexity, which is the primary enemy of the software developer. John Osterhout, in his wonderful book, A Philosophy of Software Design, defines software complexity as follows. So this book, A Philosophy of Software Design, is available online. I have a copy of it. I'll go over it in a little bit, but this is another book. So the first book is this Better Code, Better Science, and then now this is this book, A Philosophy of Software Design. So he defines software complexity as complexity is anything related to the structure of a software system that makes it hard to understand and modify the system, which is, I think, a decent definition of complexity. I would say that there are other definitions of complexity. You might, have like this as a form of kind of like maybe modification complexity or something like that. Because there are other forms of complexity in software engineering, some good, some bad. I mean, that's my take on it. Now, software solves a problem, a complex scientific problem Software that solves a complex scientific problem will necessarily be complex, but the primary goal of software engineering and design is to minimize the complexity as much as possible. So he goes through a couple of points here. The first is modularity. A key to minimizing complexity is to make our software modular, meaning that its functions can be decomposed into separate components that interact with one another only through defined interfaces. So there's this structure of modular systems. Herbert Simon wrote a paper in 1962 called The Architecture of Complexity, where he argued that our ability to understand many types of complex systems, and this ranges from physical to biological to social, relies heavily on the near decomposability that arises in systems where the different modules are insulated from each other except through specific interfaces. So this is a problem that goes way back to Herbert Simon and his ideas about complexity. So this is, well beyond software architectures, this idea of, modularity. And near decomposability simply means that you have these modules that are distinct, but they do overlap in a very simple way. So, you might have a bunch of modules that interact through a very few number of connections. I think we talked about this in DevilWorm in the context of networks. And in network theory, they have this idea of the weak tie. And there's a paper where they were referring to this as a weak tie, which is weak ties come from social systems, and I'm not quite sure that they use that terminology as was intended by the original author. But basically, they're also talking about this near decomposability, where you get these like clusters within a network, and there are very few connections that connect those clusters. Those connections, though, allow for sort of autonomous units within the network, but also that they're not cut off from communication with the rest of the network. So this is a common theme in complexity science, this idea of modularity and how complex systems often have to have the structure, because this is something that, if you have a system that emerges in very simple parts or very simple components, you tend to have things that kind of emerge as these sort of confined units, and it just makes it a more robust system. So it just kind of goes through, and then he starts talking about workflows and, kind of the things that you would do in a workflow. You'd modularize your workflow, and you have these ways of connecting your workflow together, but you do all the work in one module, and then you pass things down to another module. The things you pass down are very refined or very much a template. And so that makes sure that everything from that first step or that first module, only the things that you really need get passed down to the second module or subsequent modules. It's, this goes into this sort of reproducibility workflow mode where he says, okay, this is the complex systems lesson, and now how do you apply it to project management? This function clearly performs several operations, but viewed from the appropriate level of abstraction, it does one thing: it executes the workflow. So this is a function that kind of goes through this whole list of modules, and you write a function that allows you to go through step by step and do things within each module, and then pass things down to the next module, and so forth. Importantly, the only thing that would cause this function to change is if the workflow changed. Any changes within the components of the workflow would not require changes to this function unless they caused a change in the component function's interface. In this way, the high-level workflow manager is insulated from the implementation details of each of the components. So you insulate this global sort of procedure from the things you might do in each stage of the project. You might play around with some file, and it's something you don't want to push to the main repository. It might be in a developmental branch. You don't want to pass that down to the next stage of the project, but you do want to pass down the finished work or the sort of a summary to the next stage of the project. So I think that's it for this little piece that he talks about. It's very interesting thinking about this problem. So this is this book, A Philosophy of Software Design by John Ousterhout, and this was published in 2018, so it's a fairly recent book, and it kind of goes through some strategies for software design and how we should think about software design from this sort of philosophical point of view. So, he talks about the nature of complexity. So, of course, there's a lot more to complexity than what was mentioned in this last article. We have to think about the symptoms of complexity, the causes of complexity, how complexity is incremental. And remember, we're talking about software engineering. So sometimes we use these terms that are kind of have this universalist definition, right? So complexity across all sorts of systems, social systems, biological systems. We can't necessarily use the same definition for software design. We can use some of the same principles, but the definition is going to be unique to this field. Then this next chapter, working code isn't enough, and so we have different types of programming: tactical programming, strategic programming, how much to invest in a problem, and then some other things about startups and investment. So, just producing working code isn't the only imperative that you have when you're working in software development. Sometimes you're working on certain problems and you have to approach them in different ways. And sometimes you're not trying to build a production version. Sometimes you're just working out problems, or you might have the goal of kind of working and seeing if something can be coded and then, throwing that away in a sense, and then kind of taking lessons from that and moving to the next, to sort of the production, something that's going to lead to the production version. Then he talks about modularity and modules. So this chapter is titled Modules Should Be Deep, talking about modular design, abstractions, deep modules, shallow modules, classitis, which I suspect is the overuse of classes, and then examples from Java and Unix IO. So, we've had this discussion in some of my classes about, classitis, where you just make too many classes, you make a class for everything, and then, eventually you say, this is just way too much. We need to simplify the code base. If you're doing object-oriented programming, of course. And so there's this whole thing about managing objects in the programming environment. And it's an interesting topic, but it does go back to this idea of complexity and modularity. And then there's this information hiding and leakage. So we have information hiding, information leakage. It gives an example from an HTTP server, too many classes, HTTP parameter handling, and so forth. Information hiding within a class, taking it too far. It's some interesting stuff there. This next chapter, general purpose modules are deeper, where you want to, again, it's the interaction of classes and how you define your classes as sort of modules, or how you make them maybe less complex than the tendency is otherwise, and then kind of thinking about that in terms of overarching design. How do your modules interact? How do you make for more efficient programs, and et cetera, et cetera. Number 7 is different layer, different abstraction. So it just talks about how you would create layers and abstractions of problems. Then pull complexity downward. And this is kind of, I don't know what he means by that, but you'd have to get into the book. And then better together or better apart. Bring together if information is shared. Bring together if it will simplify the interface. Bring together to eliminate duplication. Separate general purpose and special purpose code. And then he gives some examples. And then 10 is define errors out of existence. 12 is about commenting and why you should write comments, and why people make excuses for not commenting their code. In between that's chapter 11, which is design it twice, which is just kind of an approach to design. And then comments should describe things that aren't obvious from the code. So this is where kind of gets into this good practice of commenting code. Choosing names, writing comments first, modifying existing code, consistency. These are all just kind of good practice pieces. And then getting into software trends in software design. So object-oriented programming, agile development, unit testing, test-driven development, working with design patterns, and other things. So these are all kind of trendy things that people will argue about endlessly, whether it's good or bad or superfluous. And so, he has his take on it. And then finally, designing for performance. How do you measure performance? How do you measure, benchmarks and things like that? And then the conclusion. So that is that book, and that's available. I found that on online. I can provide a copy to you if you would like. Okay. So we had some other things in the chat here. Yeah, Jesse says excuses. I don't know what that was referring to. This is.
It was just a comment about, well, a comment on commenting and the excuses for not commenting. I was
Oh yeah.
I was plus wanting that because I made plenty of excuses myself. I think that's one of the honestly the biggest, the kind of awkward like benefits of LMs in that sense is like they're pretty good at just like auto commenting when you're uploading stuff to GitHub. And it's like, oh, that's nice, but
Yeah.
yes.
Okay. All right, so let me go through these links. So Morgan posted a couple links. This is an Amazon book, 50 ML projects to understand large language models, investigate transformer mechanisms through data analysis, visualization, experimentation. This looks like it's interesting. This is the Mike X Cohen book.
Yeah, and
yeah.
and the GitHub for it is right before that, and the link in the chat. Yeah.
All right, so the right here, this one, or the global workspace, or is that different?
No. So right before the
that
link
one.
to Amazon is the GitHub. Yeah.
Yeah, this is the Mike X Cohen book. This is so this has like it's an open textbook, or is this just the details like that? Yeah, so this is just kind of going through the book, the different chapters and different lessons from the chapter. So he has these different notebooks. You have, I guess, have to buy the book and then do the lessons. Yeah, it's good. And then this is a nice kind of overview of this area, and how to follow along with that. Okay, and then there's this global workspace and language models. This is the Anthropic paper. They always have like this website that is very, very high. It has very high production values. The mind is an ocean, and then it goes up to some other things here. So yeah, and then this is the paper here. Verbalizable representations form a global workspace and language models. So this is like global workspace theory and consciousness. They have, I guess maybe this is a takeoff on what that is.
Yeah, they've put together some. There's an intro video.
Yeah,
Like,
yeah, it's
yeah. I mean, it's but there is some really great references in this, in terms of, once you get into the paper, and that I think are, sorry, I'll drop a link for Neuronpedia. Yeah.
Okay. Yeah, it looks like we have some theory of mind. We have some counterfactual reasoning. We have a global workspace, where we don't really talk about it as a world model here, but it's basically a similar concept. Yeah, so this is all good. And then let's see if we have one more link here, which is the Jacobian lens. So this is Anthropic's GitHub organization here, and this is their Jacobian lens repo. So this is where we have the companion code for verbalizable representations from a global workspace and language model. So that was that paper I just showed. This is the repo, which is the Jacobian lens. So the Jacobian lens reads out what an internal activation is disposed to make a model say. It linearly transports a residual stream vector at any layer and position in the final layer basis, then decodes it with the model's own embedding into a ranked list of vocabulary tokens. Okay, so then it just goes over the Jacobian here, and then the expectation is over prompt, source positions, and all current and future target positions, and a generic web text corpus, the precise estimator, where the cotangent summed over target positions, then average over source positions, is documented in the JLens fitting module docstring. And then the repo fits the lens on the open weights decoder transformers, applies it, and renders the interactive layer times position view, and this is shown below. Examples use QN, other Hugging Face decoders adapt cleanly. So this is the slice visualization here. All right, and then this is the Neuronpedia, which is the Jacobian lens. What is this? What is Neuronpedia with respect to Jacobian?
So it seems to be a website for really getting at different kinds of visualizations and metrics of the internals of neural networks. But not in the weight. So like. As I've said before, really interested in this area in terms of, like what WeightWatcher.ai does in terms of data free, modeling of these networks, right? So this is kind of like spectral analysis of layers. Neuronpedia, seems to be more kind of like this interpretability that you see with, that you might recognize from kind of like computer vision, where you look at, the activation states in the model that relates to the segmentation or identification of a particular object, for instance.
Okay.
Yeah. So anyway, they've implemented a lot of different ways and means to look at lots of different models and lots of different, in lots of different ways. And I think that's particularly valuable. Or, like I said, I'm kind of trying to put together, what are the educational materials for doing this kind of computational cognitive science, if you will.
Yeah, that's very good. And I'm looking forward to seeing the kind of a draft of that.
Yeah. So let's see what happens with this. I mean, like societies have thought that that particular repo is going to at least have for now some of the kind of like the tools and as applied to Blazy Agarasiarchus. Sorry. Paper in that as well as like I need to find this other paper in terms of how to improve this sort of came out with some of the work Deliberate Lab. Yeah, so the Deliberate Lab project from DeepMind, which does an arena for multi-agent communication and kind of like social experiments, and again gets at this point of how kind of degenerate a lack of diversity is in a conversation, or so you also need some metrics in terms of how to identify these things, right? Anyway, I'm going to try and put that together in this, as it relates to these reasoning models that, so he makes at least a claim. I don't know if it's a strong claim or, how important this particular paper, it was worth 100-page preprint.
Well, what
I
is
think
it?
only 30 pages of it is really kind of important. But yeah. Anyway, I think it should be good, right? I mean, I enjoyed the conversations that we had around the like can you use? I think there's some good material there around LLMs and cognitive science and how yeah, just like what should be the computational background. But if you've got links, please do share.
Well, I'm gonna head out, but good stuff today. And please send links in the chat and everything else. But take care, everybody. Bye bye.
All right. Yeah. Well, take care. Thanks.
Bye bye.
Bye.